Hey everybody, and welcome back. In this video, we're going to talk about, it says review of factoring, and it's going to be a review of factoring, but we're going to also talk about why we learned to factor to start with. So I know we've been out of school a while, and I probably should go back over some of this and remind you of where it is in your notebooks, because you're going to need to access that information to just keep up with what we do in here every day. Okay, now I will have to introduce somebody to you because she won't let me work without being part of it, so she has to sit beside me. This is Pie Pie, and she was going to bark me to death, or I put her up here in a chair beside me with her bed. So all right, Pie Pie, I'm sorry about that. Go back to bed. All right, so anyway, let's get started. Basically I'm going to review the types of factoring and then relate it to an equation. And I got 4 examples, and I want to make sure everybody kind of sees exactly why we did this. Now, I'm going to work in a Google Doc so you can see the jobs I've got to do, or the factoring, different styles that we have to factor, or different types. And I think I'm going to get a stylus pen that I'll be able to write on this thing, so it'll be a little bit faster maybe. And I can probably do that with some slides, but for now, this is all we've got. Okay, so anyway, so the very first type of factoring we ran into, and this is going way back in our Unit 7, and that goes back to Module 6 actually, but in this one's been overlooked a lot, and people forget how to do this one, so I thought that we would solve or factor one of these and then relate it to an equation. All right, so type 1 is GCF only, okay? And with this one, you're basically looking for what do they have in common? What do they have in common? Now remember, greatest common factor means the greatest factor common to each one, and quite literally. This has a factor of 3, as 6 does. 3 times 2 is 6. They both obviously have a common factor of x. X to the 1 is the largest thing they have in common. So I'm going to factor out the GCF. And remember, when you take that GCF out, you divide it out. So 3x squared divided by 3x leaves me with x. 6x divided by 3x leaves me with a 2. And that is factored completely. And if we look inside here, that is now prime. We're good to go. All right, let's relate it to an equation now. If this had been a quadratic equation, it would have looked like that in standard form. Well, we would still have it factored on the left-hand side like that. And we have a rule that says, now we set each factor equal to 0. And when I do that, let's see, put another equation in here. We have to solve this equation. And I'm just going to type the word or in here. It might look kind of weird, but we're just going to, no, that won't work. And you got or x plus 2 equals 0. And that's the part some of us skip, you know. And what you'll finally get, when we solve these equations, well, this one right here, people get confused on. I don't know why. You can divide both sides by 3, and you get x equals 0. Maybe they get worried about it, thinking that somehow you can't divide by 0, which you can't. But you're not. You're dividing by 3, not a 0. Okay, then over here, you set this equal to 0. Let me subtract 2 from both sides. You'll finally get x is negative 2. Both of those are solutions to this quadratic. Now tomorrow, I'm going to show you another way of solving these. Yet another way. Of course, this is the way you have to do it if it's calculator inactive. Right? And we do have to face that exam at some point, and this is what you'd have to do. All right, the second type we ran into back in the day when we went to school was this guy right here, an x squared plus bx plus c. And you know, we talked about it at some length in a lot of detail, and we said, well, the way these worked, and if we saw a pattern for multiplication, and we were able to write them, if you'll remember, we said, okay, now look, for these, we need to find numbers that multiply to C that add to B. So in other words, we need to multiply to 6 and add to 5. We go down our list. We have to consider everything. 1 times 6, no. 2 times 3, oh, we found it. So with these, it was really easy. Remember, we could just write the parentheses out and just go x plus 2 and x plus 3. And order doesn't matter here because multiplication is commutative. It makes no difference. Now, if this is an equation to start with, so that's just a factoring job, but if it was an equation, it would look like this, and this one would look, whoops, like this. And when you set both of these equal to 0, I told you, a lot of people go fast with these, but you got to remember you change the sign when you set them equal to 0. So x plus 2 equals 0 gives me a negative 2. X plus 3 equals 0 gives me a negative 3. And you can see by a visual inspection here, you plug in a negative 2, that makes this whole thing 0. Put in a negative 3, it makes this whole thing 0. So, just, try not to make too big of a deal out of it. But, and just to save us some time here, I'm not going to go through and solve each one of those. I'm just going to write the solutions. And you could use a comma here. It probably is better form to put them in order. Negative 3, comma, negative 2, something like that. Or actually, I think in Delta Math they use those brackets. Remember, it would look like that. This is set notation, right? So this says the set of numbers, negative 3 and negative 2. And they wouldn't have that in there. Remember, so those are solutions to the equation. Okay, moving on. Finally, example 3. Now this was the tougher customer for us. This is an ax squared plus bx plus c. Notably, this number in front of x squared is not 1. Okay, so this makes it a little bit of a tougher job. There was 2 ways of going about this. The way I've always, over the years, I found that a factoring by grouping approach tends to always work for people. But then folks feel like that's too slow. And our book, the MVP math book, says they use trial and error. That's one of their favorite methods. But we're going to do this one both ways. Okay. Now to factor this, because remember that's the first job you've got to do when you're solving these equations, by factoring. You got to be able to factor. So on the left-hand side, if it was an equation, it's not. So the first thing we'd have to do here is, if we're going to factor this thing, if by grouping, is we're told find numbers that multiply to a times c, which happens to be negative 6. 3 times negative 2 is negative 6. And they need to add to b. All right, so multiplies to negative 6, adds to b. We make a quick list. I showed you, write them down. Go through every one of them. All right, so we got to multiply negative 6. We'll have negative 6 times 1. All right, negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. That's the combination. So we would write 3x squared. All right, we need minus 6x plus, you could call it 1x if you like. We know 1x is just x. And then we got a minus 2 right there. All right, that's the first step in a grouping approach. Now, when you factor by grouping, you got to consider each group independently. This group we need to look for his common factor, and then we'll come over here and look for his common factor. Okay? So that's going to leave us need another line here. Let's put that in. Okay, so the GCF of the first group is looking like 3x. All right, and then the first group, that leaves me an x minus 2. Now remember, when you're factoring by grouping, that these two groups have to end up with a common factor. And this x minus 2 is going to end up needing to be that common factor. So when you look over here, you realize you've already got it. So in other words, this guy, all we really need is a 1. And that's all that's in common here. And you can see that. And it really doesn't affect when you factor it out, of course. And now we see that this guy has a common factor of x minus 2. Oops, I need to bring that whole thing down so we can see it. All right, so everybody's got a common factor of x minus 2 here. And finally, we can factor that out to give us, all right, now That's what's in common in each one of these groups. And it leaves us, when we divide it out, the 3x and the 1. And again, order doesn't matter here. Now, if you look at this, you need to make sure you're checking these by multiplication. You get 3x squared, x times 3x is 3x squared. Yeah, that works. Negative 2 times 3x is negative 6x plus the 1x from the outer terms, and then negative 2 times 1 gives you that negative 2. It worked. Okay, so now let's consider this. What if it was a quadratic equation? We know how to factor it. That's what the whole job's about. Well, you're going to set these equal to 0 just like we just did. We can tell this guy's going to be the easy one. X minus 2 equals 0. It's going to give you that positive 2. However, right here, a lot of people have been kind of messing this up a little bit. So let's actually do that one and show it. And I keep on, you just have to bear with me on this stuff. It's not the most ideal way, but you know it does work. So I'll take it. Okay. All right. So when I set these equal to 0, I really want to solve this equation here. We know the easier factor, but this one right here has been causing some grief for some folks. All right, go back to your early algebra days. You're just going to simply need to isolate this x. So you subtract 1, subtract 1. Well, 0 minus 1 is negative 1, right? So then this gives us 3x equals negative 1. Now, to finish this up, you'd have to divide by 3. So finally, you're going to get x equals negative. Oh, this thing has a goofy fraction feature here, so you'll have to forgive this. Watch this. Yeah, negative 1/3. And that's what you'd have. Okay. And again, they would put these in those set notation brackets. So the solutions would be positive 2 and negative 1/3. And it would look like that. Of course, the x equals wouldn't be in there, but this is how they would write it. If you were doing this in a Delta Math assignment, that's what they would have, which is the right way to write it. Right, those are your solutions. Okay.